Hi guys, my name's Katherine. I'm one of the tutors here at Chegg. I tutor science, some math, English, and Spanish, and today we are going to be talking about a chemistry topic, which is dynamic equilibrium. So when you have a chemical reaction like the one that I've drawn out here, you have your reactants, which are the things on the left, and you have your products, which are the things on the right. So for clarity. These are reactants, R for reactants, and then this here is the product, P for products. And whenever you have a chemical reaction, typically what you do is you put in the reactants and it makes products, but those products will often react with themselves as well to make reactants again at a certain rate. And the rate that these things, the reactants, are becoming products is not the same, at first at least, as products are becoming reactants. So in this reaction, which is hydrogen gas and iodine gas, make HI, also a gas. Say you have a closed container, meaning it's a closed system, things can't get in or out, and you put in a bunch of reactants. You put in a bunch of hydrogen gas and iodine gas, and you close it up. So what happens is you have a lot of those reactants, and so they'll immediately start making HI. But as time goes on, as the hydrogen and the iodine gas start getting used up, the rate that that's happening slows down. But at the same time, the amount of HI is building up in that container. And as there's more and more HI, it reacts with itself more and more. So two HI molecules interact with each other to make a molecule of hydrogen gas and a molecule of iodine gas as well. And as that starts to happen, you get a little less HI, and then that's less likely to happen too. So what dynamic equilibrium is all about is the balance point between the two. Because what will eventually happen is that the amount of hydrogen and iodine gas in the system is unchanging, and the amount of HI gas in the system is unchanging because all of the products and all of the reactants are being made at the same rate that they are being used up. So another way of saying that is that dynamic equilibrium happens when the net change of a reversible reaction becomes zero. Now, it's important to note that that doesn't mean that there's no change happening at all in the system. You still have these two gases becoming products and products becoming reactants. So it's not true that there's no change at all in the system. It's just that the net change is zero because, like I said, every molecule that's becoming the reactants is being replaced immediately by some reactants that are becoming products. So say you have this closed system and it has reached dynamic equilibrium. The amount of all three gases is constant in the system. And then you add something to it. Well, what would happen? So if you add products, so if you add a lot of HI, you'll get what's called a leftward shift. So what happens there is the rate of the reaction from products to reactants speeds up, at least for a little bit, because you have way more products, and and with more products around, there's more HI to interact with itself, and so it starts making reactants faster. But with more free reactants, those reactants are able to make products faster, and eventually it balances out again. If instead you add a lot of hydrogen gas or iodine gas, or both, what will happen is you'll have a rightward shift. The rate of the reaction in the rightward direction from reactants to products will speed up. The reactants will become products faster, but because of that, you'll then have more products, and those products in turn will become reactants faster. So in either case, what ends up happening is it reaches balance again. But the rate of the reaction, once the volume or the amount of each of the three things has been changed, won't be the same as it was before. But it will reach a net rate of zero eventually. And that's what dynamic equilibrium is. I hope you enjoyed this lesson. If you did and you would like to seek me out on Chegg for private tutoring, I would really appreciate it.